In this video, we're going to look at example 2, where we simplify a rational expression. So the questions posed are, what is the simplified form of the rational expression, and what is the domain for which the identity between the two expressions is valid? All right, so remember, in the last video we mentioned we have to be careful with domains, so let's keep that in mind. A simplified form of the rational expression is going to be where we can't cancel anything out, right? Simplified form has no common factors outside of 1, and in the numerator or denominator, right? There's no common factors. So our first step would be to factor. And the numerator, although it's kind of, let's say, backwards, we're used to seeing something like this, it is the difference of two squares. So 4 minus x squared, sorry about that, can be factored into 2 plus x times 2 minus x. All right, remember that's the difference of two squares. 2 times 2 would give us 4, x times negative x would give us that negative x squared. Right, and then the denominator, we need to find factors of negative 10 that have a sum of 3. So again, like I mentioned in the last video, I'm not going to go into crazy detail of factoring. Hopefully you have a pretty good understanding of that by now, and if not, just go back to previous videos. So factors of negative 10 that would add up to 3, I'm looking at positive 5 and negative 2. Right, 5 times negative 2 would give us a negative 10, and 5 plus negative 2 would give us a positive 3. Now, this is where textbooks like to be tricky and kind of confuse students. These two expressions look kind of similar, but remember that 2 minus x and x minus 2 is not the same thing. All right, if I did 5 minus 3, that's definitely not the same as 3 minus 5. So I do want to be careful with that. However, what I am able to do for this piece here, I can factor out a negative 1, and I'm going to write that off to the side. So if I had 2 minus x, and let's pretend I factored out a negative 1, I would get negative 2 plus x. And then what I could do is instead of writing negative 2 plus x, I could rewrite that as x minus 2. So that's what we're going to do here. We're going to change this 2 minus x, keep messing that up, this 2 minus x, and we're going to factor it again, use some kind of tricks, we'll call them tricks of the trade, where you can take that negative 1 out. So that's going to become, in my numerator, let's keep the denominator the same. I've now factored out that negative 1. I'm going to put that negative 1 all the way out front. And then here I'm going to keep the 2 plus x. I can even rewrite that as x plus 2. That'll make more sense for us. So rewrite that as x plus 2. And then what was 2 minus x is now going to be rewritten as x minus 2. Now it's really important that we remember we didn't just switch the 2 minus x into an x minus 2. We factored out a negative 1 so that we were able to rewrite those terms. And all of that work is done over here. All right, now that I'm at this part, I can look for, let's say, common factors. All right, and common factors in this one, I see that I have an x minus 2 in both the numerator and the denominator, and I'm able to reduce those out. All right, those would be the equivalent to 1. So what I'm left with is negative 1 times x plus 2 in the numerator over x plus 5. And we can write it that way, or if you wanted to, we could write it as negative and then x plus 2 and x plus 5, where that negative is kind of in front of the fraction. Okay, so either one of these could be our solution. And be careful, or just keep in mind, it says what is the domain for which the identity between the two expressions is valid. We don't want to look at the domains at the very end. We want to look at the domains after we've factored. Okay, so we want to look at the domain on this step here. So my domain, we have all real numbers, except, well, for this first expression, x plus 5, we cannot have negative 5, right? Here, that can't be negative 5. And then here, x cannot be positive 2. All right, so we'll wind up with 0, and then we'll have an undefined expression. So my domain from here where we factored it is there, but this domain also applies here. All right, so don't forget that the domain applies to your final answer, but you do need to find the domain from the factored step. Once you cancel things out, if you want to look at the domain in the final step, we wouldn't have realized that we can't use 2. So do be careful with the domain. Take your time with that. The domain, I'll say it a bunch of times, should always be figured out after the step where you factored. Okay, so I'm just going to circle that so we keep that in mind.